welcome back to CodeVerse. So today we're gonna see the very important topic of data structure. It's called arrays. And we'll start. We're going to read today about data structure. So our main topic is arrays, but we're going to see the linear and non-linear data structure. If we'll talk about linear data structure, then we have first arrays, and second we have linked list, and third we have stack, and fourth we have queues. Okay, and if we'll talk about non-linear data structure, then first of all we have trees, second we have graphs, and hashing. This hashing comes under both, and sometimes we use linear as well as sometimes it also we use as a non-linear. Okay, so for today's our main topic is arrays. We're going to see the definition and the important concept. We're also going to see the 2D arrays, 1D arrays, and all. Okay, so we'll talk about arrays. So what is arrays? It is a collection of similar type of data, or we can say it similar type of elements. Okay, and the second we see that in in mainly computer system, the index is always starts from 0. Index will start from 0. The third point is that the elements are stored one after another. First, we can't. Most of the elements are stored in the sequential manner, and all these elements can be randomly accessed. Okay. So third point we can say we have a advantage of random access of these data, and fourth point we can say that we have also the advantage of relative addressing. Okay, so if I take one example, if I'll take one example I'm declaring an array of name A and size I'm taking 10, and we all know by default it is of 4 byte. It varies from system to system. Okay, if I'll take the array of int type and the name is A and the size of the array is 10, so it means that the index will start from 0 to 9, because by default the index starts from 0 in any system, or we can say especially in C programming language. So suppose if I try to show how the data will look. Zero. So this is array of 0, this is array of 1, array of 2, array of 3. Okay, so this last box is extra. I'll remove this. Okay, this is extra. Okay, now. So as the size of array is 10 and we have declared the 10 and the index will go from 0 to 9. So suppose if I'll give the base address of all these elements like this, it will start from 1000 and 1004 because it is of int type and int is of 4 byte. Okay. Then 1008, 1012, 1016, 1020, 1024, 1028, 1032, 1036, and 1040. So this is how after giving the base address and after giving the address of the each index, how an 1D array looks. Like if I'll say address of a of 0, then it will be starting address. Okay. And if I'll ask address of a of 2, then it will be 1008. Okay. So now we're going to see like what type of question will come from this, like especially from 1D array. Okay. Suppose they'll ask like right now, see that I've taken the size of array is 10 and this is very small size, and what if in the examination the question will come, they'll ask and they'll give the size like 1000, 2000, and they'll ask the address of a particular element, right? Then it will be very difficult to find and it will be very difficult to plot and plot and to get the address of this. So we'll going to see in the question that how we can handle these types of questions. Suppose if I'll take, like suppose we have to find the same question. Suppose in the same question, okay. Suppose we have to find the address of a of 2. By looking, you can see that the address of a of 2 is 1008. But in the question, we'll see by using formula or using formula and tricks, we're going to find the address, right? So suppose first of all we have to find like how many elements before a of 2 is already filled, right? Like suppose so here the index will by default the index will start from 0, and what we'll do, I'm asking how many elements before a of 2. So the element which is before a of 2 is a of 1, right? So what we'll do 2 minus 1, that is 1. So it will go from 0 to 1. So how many elements are there? What we'll do, we'll use the formula here like this like last minus first plus 1. Okay, so here the last is 1, first is 0, and we are adding 1, so it will be 2. So before a of 2 we have two elements which is already filled, and if you will see in this diagram also, two elements are there which is before a of 2 is already filled. So right now we can say that there are two elements which is already there before a of 2, right? This is our first step. Second step is that we'll going to calculate the size. As because the size is already there, I'm dotting sizes of 2. Let's take the sizes 4 byte. Okay, suppose w is of 4 byte, so there are two elements. So from here we'll calculate memory already filled. What we'll do for this, we multiply the number of elements into the size. It will be 8 byte. Suppose in the question we have the base address, In the diagram we have the base address is 1000. So we have to calculate the address of A of 2. So what we'll do, the required address is 1000 plus 8, that will be 1008. So in this way we can find the address of any element, especially in the 1D array. Okay, now this is one type of question. Suppose in the 1D array only, like if other type of question will come, like suppose the array is of starting from 20 and it will go till 10, right? Because in the examination or in theory they can give the starting address anything, not uh, the starting index is 0 is only in the C programming language, but in the theory they can the starting index will be anything. Okay, suppose this is our array and I am taking addresses, like sorry, the size is 2 byte and the base address I am taking is 1000, right? So our first question is we have to find the address of A of minus 5. Okay, so what was our first step? We have to find the number of elements which is already filled. Okay, so for that what we'll do, like it will start from minus 20 and from here we'll do minus 1. So minus 5 minus 1, then it will go to till minus 6. As now we have to calculate the number of elements which is already filled by using last minus first plus 1. Okay, so last minus of first plus 1. So this will be like minus 6 plus 20 plus 1, it will be 15. So there are 15 elements which is already filled, and this our second step was memory already filled. So it will be 15 8 to 2, that is 30 byte, right? Yeah, so it will be 30 byte. And our final step is that, as in the question the base address is 1000, so our the required address for this particular question will be, what we'll do, simply 1000 plus 30 byte will be 1030 is the required address which had asked in the question, and this is our answer. So this is the case of 1D array. It's like here I'll tell you one thing, that what is really happening at this points. Like suppose this is our array. Okay, so here what is happening till here? It is 30 byte and our starting address is 1000. So after adding this 30 byte, we are getting 1030, and this is the address of array of minus 5. So till that we have seen that how the 1D array and what type of questions will come. Now we'll going to see, like now we'll mainly focus on this 2D arrays. Okay, wait a minute. I should use the black point. Okay, now. So as you all have seen that how 1D array and what different I have discussed two different kinds of question. Now we'll see a 2D array and what kind of questions will going to come. Right? Suppose if I'll take for example, like if I declare one 2D array, a of 2 and it is of like 2 by 3. So how it looks, 0 1, it will be 0 1 2, right? So it will be a of 0 0, a of 0 1, a of 0 2, a of 1 0, a of 1 1, and a of 1 2, right? Here the number of elements in the row with index 0, the number of element in the row with index 0 is 3, right? And the number of elements with index 1 is also 3, right? So we can say that the every element, like every element in the row in a particular index, like suppose here we have two rows, that is 0 and 1. So index like element with index 0, the total number of elements will be 3. In the one also we have 3, right? So what is like suppose we'll plot this, how it really looks like. This part is this array of 0, and this part is array of 1, and we have total three elements with index 0 and with index 1, right? Suppose if I take one more example, so array of 3 comma 3 by 4, right? So what we can say that here with the row with index 0, the row with index 1, and the row with index 2, each rows will have 4 elements, right? That's because this, what this denotes, the column, and this is denoting the rows. So like every index with every row with index 0 and with index 1 and with index 2, we have four elements in each row, right? So that's it. Now we'll say like there are mainly two kinds of uh, a 2D array we will have. First one is RMO, like RMO, and second one is CMO. This is the row measure order. This is row measure order, and this is column measure order, right? So what happened basically in this type of array? See, suppose first if I'll take a row measure order, right? Suppose in the row measure order, uh, I'll draw one matrix. I'll take the same example which I had taken earlier. I've taken array of 3 by 4, okay? So this will be array of 0 0, array of 0 1, array of 0 2, array of 0 3, array of 1 0, 1 1, 1 2, 1 3. This will be sorry, this will be 2 0, there's nothing, okay? 2 1, 2 2, 2 3, okay? So in the row measure order, what will happen? Suppose if I'll take like this. Okay. Okay, now this one is row with index 0. This is row with index 1, and this is row with index 2. As I've told that each index have 4 elements. Each index will have 4 elements, okay? So 4 boxes, 1 2 3 4, okay, done. Here also 1 2 3, total 4, 1 2 3. So here total we have 4 elements in each row, right? Like this will be A00, A01, not so sorry. Right now we are using row measure order, right? So what we'll do, elements will be filled in this manner, okay? Like A00, A01, A02, A003. Again from this A10, A11, A12, A13. Again, we'll start from this 820, 821, 822, 823. Okay, so this is how it really looks. Suppose if I'll ask, suppose you have to find the address of particular element, that is 823. Right? Suppose I'll give the base address of all these elements. Suppose it will start from 1000, 1040, then 108, 1016, 1020, 1024, 1028, 1032, 1036, 1040. I have done some mistake, I guess. Yeah, I have missed something. Okay, 1000, 1000, I'll write directly. This will be 1004, 8, then 12, then 16, then 20, then 24, then 28, 32, 36. This will be 40. This will be 44. Okay. Here, this element will come. Suppose I have to find the address of 823, right? So we'll suppose that we have to find the address of 823. So we'll follow the same steps that we had done with done with 1D array. First, that we will find how many elements. Actually, this is a row major order, right? So we'll mainly focus on this row, right? So for this, we'll see how many number of elements, like how many number of, first of all, we'll see how many rows are already filled, right? How many rows are already filled before this element. So by this representation, we can say before this element, there are two rows which is already filled. Then our second step will find like how many elements are there before this element. How many elements are there before this element? So here we can see before this we have three elements, right? And then third step, what we'll do, we will again follow the same rule that we'll find the total how many memories were already filled. At the end, we will add that particular size of memory with the base address. Then we'll get the address of this particular element. Okay. So, first step was we have to find the number of rows which is already filled, right? So, as our array was a of 3 comma 4, right? Okay, now our first step is rows already filled. Okay, so what we'll do, as we can see, this starts from, by default it will start from 0 to, we'll do 3 minus 1, that is 2. So again, we'll use the same formula, that is last minus first plus 1, that is 2 minus 0 plus 1. No, wait. No, we are finding this is array address of a of 2, 3. No? No. Thought. Yeah. By using this, we can say that our array is starting from index 0, and suppose here you have to find the address of a of 2 of 3. So we'll do 2 minus 1, that is 1. Again, we use the formula that is last minus first plus 1, that is last minus first plus 1, that is 2 rows over there, not 2 rows. So as I've already told that each row has how many elements? 4 elements over there, right? So we have 2 rows. Total number of elements will be 2 into 4, that is in 2 rows we have 8 elements. Got it? Like till here we have solved, that is till here we have calculated that the total number of elements is 8, that is okay, 4 plus 4 8. Now we'll in this next step we'll calculate this, how many elements were there before a of 2 of 3. So for that what we'll do, we have to use this. Okay, here the number of elements which is already filled, right, before a of 2 3. For that what we're gonna do, we'll use this, we'll go from 0 to 2. Okay, 0 to 2 because it's starting from 0, and here 3 minus 1 is 2. We are again, we will use the same formula, that is last minus first plus 1. It will be total 3 elements are there. Okay, now total elements is 3 plus 8, that's 11 elements were there. Now the size of each element is, as you all can see, it is 4 byte. So a third step is memory already filled. It will be 11 into 4, that is 44 byte. So now what we'll do, we'll add this size of memory with our base address, that is 1000 plus 44. So our answer is 1044 byte. So this is our required address. Now this was example for the row major order, right? Now we'll see one example for the column major order. Okay, we'll see the example for column major order. So in column major order, what we'll do, like in the row major order, the elements are filled in the row manner, right? That will go from 0, like A00, A01, A02, A03, right? If I'll take this diagram, in the row major order, we are filling the elements in this manner. Okay, first, second, third, right? A00, A01, then A02, then A03. In the column major order, what we'll do, we'll fill the element in this manner, like A00, A10, then A20, then again A01, A11, A2, A21, like that. So if I'll take one example, suppose we'll have to find the address of, if I'll take A of, again I'll take this, for example, if I'll take the same example, right, A of 2 3. So here, and our size of array was 3 comma 4. So now I can see that the row, that the column with index, we have total 4 possibilities, no? 0 1 2 3. You can see that the column with index 0 have 3 elements, right? Column with index 1 also have 3 elements. Column with index 2 also have 3 elements, and column with index 3 have also 3 elements, right? In the row major, what you were doing, like column, that row with index 0 have 4 elements, row with index 1 have 4 elements, and row with index 2 have 4 elements. But in column, go with we'll focus on the number of elements in the particular row, because in that manner only we are filling the elements in that particular array table. Got it? Suppose if I'll take one small example here, like wait, suppose I will take one example, like I'm declaring one array int a of 2 3. So like it will be 0, then 1, 0 1, then 2. Okay, if I'll write this element in the matrix form, it will be a 0 0, A01, A02, A10, A11, and A12. So in the row, in the column is order, what we'll do? Okay, here we have total. Here column with index 0, column with index 1, and column with index 2. And each column with index 0 or with column with index 1 or column with index 2, with total how we have how many elements? Two elements, right? So it will be array of 0 0, array of 1 0, array of 0 1, array of 1 1, of 0 2, array of 1 2. So this is how this indexing looks like, right? Okay. Suppose in the previous example, like in this example only, right? In this example only, if I'll take the starting address as 1000 and suppose the size of that we have a W is equals to 4 byte. So it will be 104, or like 1008, 1012, 1016, and 1020. Suppose that we have to find the address of uh, A of 11. Suppose like in the question to find the address of A of 11, right? So what will be our steps? So the steps will be same, but right in the previous question we did that for the rows. Right now we'll do the same thing for the columns, right? So here each column with index, like our first step was you have to find the number of columns already filled. Number of columns already filled, right? Here we are looking for this. So for the number of columns which is already filled, as our index start with arrays and with 0, we'll go to what this one will focus on this, right? So minus 1, it will be 0, but what we'll do again, last minus first plus, that is 0 minus 0 plus 1, that is one column is already there, right? And as I've told that each column has how many elements were there? Each column has how many elements were there? Two elements were there. So here we have 1 into 2, that is presently we are done with 2 elements. Okay, now we'll focus how many number of elements before A of 1 1. How many elements were already filled before A of 1 1. For that we'll focus on this, right? We'll focus on this. Okay, so what we'll do again, it will go from 0 to 1 minus 1, that is 0. Again last minus first plus 1, again it will be 1. One element is there, right? No, before this one element is there, right? Now we'll see total elements, that is 2 plus 1 is equals to 3 element. Okay, and the size of each element is 4, that it will be 12 byte. As our base address is 1000, so our final step is we'll add this memory to our base address 1012. Got it? So the size of the address of this one was 1012, and we are getting the same value. So this is our answer. So this is for today, and I hope you all like this video, and this way we can solve the questions and we'll find the address in 2D arrays and 1D array.